Hello everyone, this is Akang Suman here. Now we are going to discuss the next topic, that is what governor. We have seen the basic concept of the centrifugal governor. What governor? Basically the simplest form of the centrifugal governor. So this is the simplest form. We have seen the working principle of centrifugal governor. So this is the simplest form of centrifugal governor. What is the aim of the centrifugal governor? What is the principle? Working principle is what? It is used to maintain the mean speed of the engine. It is used to control the mean speed of the engine. In the what governor? In the governor, we have seen there is a fly ball and there is a spindle axis and there is a bevel gears and as well as there is a sleeve. So in case of what governor, sleeve is massless. There is no mass of the sleeve. So one another point is sleeve is massless. That is important. Sleeve is massless. Now we need to draw the diagram of the watt governor so that we are able to understand it properly. So that is I am going to draw. This is the arms of the watt governor, and see one more thing that the pivot point may be at the point of intersection, and pivot point may be offset from the spindle axis. This is our spindle axis. Okay, so this is the link which has going to be attached with the sleeve, and we all know that the sleeve is massless in case of watt governor. Okay, this is the sleeve which is massless, and they are having the fly ball. I'm assuming that the m is the mass of the fly ball, and both the balls are having the same mass, and this is the point O, or you can see this is the point of intersection or pivot point, because both are pivoted at that point of intersection. And this is the spindle axis about which the ball is going to be rotated. Okay, so if the ball is going to be rotated about that spindle axis, here I'm just writing that this is the spindle axis. Each and every term you need to understand in the diagram, because the governor problems generally require the diagram. You need to understand, you are able to draw the diagram of the governor, whatever be the governor is given in the questions. So every term you need to understand where and how it is going to be used in the type of governor. So here you can say this is the spindle axis, and this is the radius of the r, which is measured from this center of balls to the spindle axis. This is the r. Okay, and we all know this is the height of the governor, and r is the radius of the governor. Okay, this is the height. So you can see here there is a ball m, which is having m mass, and this is going to be rotated about the spindle axis. And when it is going to be rotated about the spindle axis, it is having the centrifugal force outward, in the outward direction. So that would be centrifugal force. I can write that m r omega square. Yes or no? M r omega square. And it is also having the mass m, so that's why it is having the weight in the downward direction, that is mg. Okay, so this is what the centrifugal force I'm writing here, centrifugal force. However, you all know that what is the centrifugal forces. Centrifugal force, it is denoted as Fc, and Fc is equal to mr omega square, where m is the mass of the fly balls, and r is the radius of governor, and omega is the angular velocity of the governor. Okay, so you can write it as omega is equal to 2 pi n upon 60. Okay, where n is the speed of the governor in rpm, where omega is the speed of the governor in radian per second. Okay, but you need to understand there are two forces which is working on the flywheel. The first is mr omega square, and the second is mg. Okay, and the direction as shown in figure. Now I'm taking the moment about point O. I'm taking moment about point O. So when you take the moment about point O, which is also the point of intersection about O, which is also the point of intersection, what would happen? See, this is the mr omega square and it is in that direction. So it would be perpendicular distance, force into perpendicular distance. And what is force? Summation m is equal to 0, and this is the mr omega square multiply what is the distance, perpendicular distance, that is h. Okay, this is mr omega square, direction of force in that direction, and the perpendicular distance, that is h. So multiply h, and this is making in the clockwise direction, while when I'm taking the mg force and I'm taking the moment of the mg force, we can see here that mg moment is in anti-clockwise direction, so I'm considering negative sign for anti-clockwise. So that is mg multiply what is the distance from the center of the ball, that is the weight of the ball, to the spindle axis point of intersection, so that is small r, and that's equal to 0. So when you solve this, you will get the value of, you can see here that will be cancel out mr and mr, you will get the omega square is equal to g upon h. Okay, from here you can write it as h is equal to g upon omega square. Okay, if you want to write these equations in terms of the rpm, so you will get the n square is equal to 895 upon h. Or here, from here you can get the value of the height of the governor. So from here you can get the value of height of the governor. General formula for the word governor, you must have to remember that directly, because directly questions come in the examinations. You just have to put the formula and get the answer, n square. So that is the value of the height of the governor, but this is only for the word governor, that is n square. Okay, this is the formula for finding out the speed and the height of the governor. You can see here we will do an experiment on the watt governor in order to see the what is the advantage or disadvantage. Okay, what are the limitations for the watt governor. So in the next case we are doing experiment. In case when we do experiment, first I am going to consider n1 speed. Experiment first, I am considering experiment first, in which I am assuming n1 is equal to 15 rpm. When you put the n1, that means the speed of the governor is 15 rpm, you will get the value of height of the governor, that is 895 upon h n1 square. Okay, so that is h1. When you do in the second case 20 rpm, this is a part of the first experiment, you will get the height of the governor, that is 895 upon 20 square, or here you can say this would be 15 square. Okay, that is 20 square. You will get some value. Okay, when you solve it. But what is we need to understand that sleeve movement. However, our sleeve in the watt governor is massless, but there will be a movement of the sleeve. Okay, when you increase the load of the governor, there will be a decrease in the speed of the in the speed of the engine, so there will be a sleeve movement which is in downward direction. The sleeve movement. What is the sleeve movement? Basically, sleeve movement is see in the diagram. You can see here. When you increase we all know that the sleeve is movement in the upward and downward direction. So if there is a movement of the sleeve in the upward direction, what will happen? The flywheel will somewhere here. Okay, so here you can see there will be decrease in the height. Okay, so sleeve movement, if the sleeve movement is in upward direction, there will be a reduction in the height of the governor, and as the sleeve movement is in the downward direction, you can see the height will increase. Okay, so that is why, what is the sleeve movement? Basically it is the final height minus initial height. Okay, that is h2 minus h1. That is the sleeve movement. You can find out the sleeve movement, you will get the some finite value. Okay, but in the experiment too, because we have considered, low velocity, low speed of the, you can see there is a low speed of the governor. Now I'm considering the higher speed, that is n1 is equal to 80 rpm. 80 rpm I'm considering, n1 is equal to 80 rpm. And in case of when there is a n1 is equal to 80 rpm, you can find out the height of the governor. Okay, so that would be same formula, that is 895 upon 80 square. Okay, so when you do n2, when you find out the height of the governor in case of second, uh, when there is a n2 is equal to 75 rpm, you will get the value of h2, that would be 895 upon 75 square. Okay, here you can see, when you make a square, you will get 895 upon that would be 6400, and that would be something like that. Okay, this is basically, if you want to find out the sleeve moment, what you can see that when you see the sleeve moment, it would be h1 minus h2, higher minus lower, higher minus lower. Okay, here you can see this is very less, very less. So as you increase the load on the engine, there will be a reduction in the speed of the governor. Okay, are you getting my point? So in case of n2 is equal to 75 rpm, what I have done, I have increased the load. As I increase the load, there will be a speed reduction. Okay, reduction in speed, so there will be a some value of the height of the governor. Okay, when you find out the sleeve movement using this data, you will get the value which is very less than 1. So at the higher speed, the watt governor become insensitive. That is the important thing that we must understand. It should be noted that, what is the conclusion, that at higher speed watt governor become insensitive. If you want to know the exact value of the speed, so it would be 60 rpm. 60 rpm. At n greater than 60 rpm, watt governor become insensitive. Watt governor become insensitive. Generally in the questions, generally they ask you to they ask you to find out the velocity, that means the speed of the governor beyond which the watt governor become insensitive, that is the 60 rpm. Basically if you want to know the range, so it would be 60 to 80. Okay, but exact value is 60. Watt governor become insensitive. I hope you are getting my point. How can we find out the height of the governor, height of the watt governor? So that is why it is not working for the higher speed. So that is why basically we can say this is the failed governor. When there is a low speed, we can use watt governor, but at high speed, it will be completely failed governor. Okay. So I hope in the watt governor, what is the thing you must remember? That is height of the governor. You must remember that is 895 upon n square. Or the basic understanding is that there is a moment which have summation of moment which have becomes equal to 0, so that we will get the value of height of the governor. One more equations you can learn that in terms of omega. How can you find out the height of the governor in terms of omega? Okay, so basically these two equations, but most important is this. Okay, so this was the watt governor